Hello. The script for this video was prepared by Seneca Alboy from Axiologic Research and is narrated by an AI. Welcome to our presentation, which offers insights on blockchain applications for enterprises, with a particular focus on the author's experience in the PharmaLedger research project and Axiologic's collaboration with the PharmaLedger Association. This collaboration primarily involves implementing blockchain use cases in supply chains and medical data management within enterprises. Now, let us delve into the insights we wish to share today. This presentation offers the perspective of the creators of OpenDSU technology, but we believe it generally applies as observations for enterprise blockchain solutions and can illuminate certain difficulties and challenges related to adoption. In the fundamental insights underlying the architecture and ideas of OpenDSU, we can identify three types of insights about smart contracts, digital sovereignty, and the challenges to blockchain solutions adoption. For smart contracts, we start with the idea that their use always raises issues of confidentiality and scalability. This is because if the entire state of the contract is shared in real time with all network members, we can observe that this sharing is not really necessary in most enterprise applications. Here, business processes are almost always relevant only to a small number of participants. Global consensus and on-chain integrity validation of all notarized items in the blockchain are not necessary except for cryptocurrencies, and in some cases for modeling digital property like NFTs. Even for NFTs, the correspondence with the real world is more important than any on-chain correctness verification. For such cases, zero-knowledge proof offers a solution. In most other scenarios, our research related to OpenDSU indicates that microledgers are a superior solution. This is because only the anchored data, notarization information, and metadata about changes are shared and nothing else. It is a simplified form of ZKP that scales effectively and offers privacy by default and by design to the entire solution. Regarding digital sovereignty, it is crucial for use cases involving patient data. It is also very important for small players in the supply chain to avoid sharing data with third parties that could weaken their business, and it is generally beneficial for society. This point cannot be overstressed. The resilience of society relies on proper digital sovereignty. Otherwise, global risks and vulnerabilities will eventually be exploited in serious ways, damaging the core of social trust and putting everyone in danger. From this perspective, I invite comments and discussions on the role of decentralization and digital sovereignty in choosing enterprise blockchain architectures. As we will see in this presentation, there is generally an inertia among architects in pharma companies to use familiar approaches and a bias against using digital wallets, even though a future where modern cryptography ensures digital sovereignty is unlikely to exist without digital wallets. We begin this enumeration of insights with the regret that many of the benefits of blockchain are technical in nature, related to security and privacy, and are hard for business people to quantify. Additionally, cryptocurrency scandals impact perception and slow down the faster evolution of the field, somewhat favoring larger players and less so genuine innovation. Through these diagrams, we aim to highlight two qualitatively different approaches to blockchain architectures. On the left, we illustrate the OpenDSU approach, which avoids on-chain smart contracts and promotes off-chain microledgers, also known as self-validating data, SVD. This approach ensures the creation of solutions that are agnostic to both blockchain technology and the smart contracts used, thereby providing an enhanced capacity to adapt to the evolution of blockchain technologies. For instance, consider projects that become unmaintained due to lack of traction, such as the recent case of Quorum being replaced by Hyperledger Besu. While we don't know how successful Besu will be, we do notice a force pushing many use cases towards a transition to Hyperledger Fabric, which is perceived as more stable and supported by a larger community. The right-hand side of the diagram emphasizes the fact that all enterprise blockchain technologies attempt to solve the issue of confidentiality at the smart contract level, which, from our perspective, is a mistake. Such solutions will inevitably become complicated, fragile, and encounter issues related to performance, scalability, and integration, especially for small players or individual users like patients. In general, solutions based on Hyperledger Fabric privacy mechanisms, such as channels and private data collections, exhibit tendencies toward hidden centralization. This centralization is often masked by the complexity of deployment and the fragility of decentralization and confidentiality enabling mechanisms. Moving forward, we will discuss more about centralization, but let's conclude by saying that achieving real privacy by design and by default, and especially obtaining digital sovereignty for each participant in a blockchain network, implies moving away from smart contracts and towards granular data sharing where sufficient, or the use of microledgers. These can be envisioned as simply ad hoc blockchains, shared among a minimally necessary number of participants, but continually anchored in a common blockchain to ensure the immutability provided by a blockchain shared with a large number of participants. A significant insight from our collaboration with PharmaLedger was understanding the risk-averse nature of large companies. These organizations often opt for replicating proven success models rather than pioneering new innovations. Although safe, this strategy can result in a limited number of dominant software providers, suppressing innovation and leading to a winner-takes-all market. This can cause consumer lock-in and lead to neglect in quality, pricing, and customer service, resulting in market inefficiencies and diminished innovation. The PharmaLedger research project was initiated to develop an open-source blockchain platform akin to Linux for various blockchain applications. The objective was to establish a universal standard promoting competition and innovation, thus nurturing a diverse ecosystem with multiple product options. OpenDSU, a pivotal technology within PharmaLedger, enables secure data exchange in digital trust ecosystems. It's compatible with other blockchain technologies and enhances trust and data sharing without needing to replace existing databases. Our work with PharmaLedger highlighted that no single blockchain solution fits every scenario. A successful platform must incorporate a range of concepts to cater to both small and large entities in the ecosystem, including wallet integration, data sharing standardization, privacy concerns, and the limitations of on-chain smart contracts with sensitive data. A multi-ledger approach is crucial for scalable industry-wide applications. The layered platform architecture addresses the complexity and varying needs of stakeholders in a digital trust ecosystem. Our analysis of existing enterprise solutions showed a heavy reliance on APIs and databases, which could lead to centralization. OpenDSU offers an alternate route, ensuring the blockchain acts as the trust anchor with standardized APIs for data interchange, thus fostering interoperability. Concerning APIs, OpenDSU introduces a decentralized model via the Blockchain Domain Naming System, BDNS. Without a BDNS-like mechanism, blockchain solutions for mobile apps or websites would inevitably hinge on centralized gateways. The section marked in red in the diagram is indicative of a common approach in many blockchain setups. Dependence on these centralized API gateways practically annuls the benefits of blockchain. In environments where trust is vested in the API gateways, employing blockchain becomes redundant and counterproductive. Acknowledging this fact and opting for suitable solutions is more pragmatic. While decentralization may seem impractical to some, preferring trusted intermediaries, OpenDSU showcases the practicality of decentralized approaches. OpenDSU also allows a seamless transition from centralized to decentralized models, not by massive change in architecture, but by substituting components. In conclusion, our experience with PharmaLedger emphasizes the need for flexibility, diversity, and decentralization in developing blockchain solutions for enterprise applications. Let's introduce some concepts and concerns that we categorized as layers impacting the architecture and thinking about blockchain enterprise solutions. These concepts aim to support our key insights. Throughout the PharmaLedger project, we identified 5 major aspects affecting blockchain platforms, best represented in a pyramid structure. Each layer holds an equal impact, but the foundational layers often have a larger influence due to their ability to significantly influence decisions in the superior layers. The base layer is secure data sharing and data segregation. These aspects are fundamental to any decentralized and multi-stakeholder platform architecture. Secure sharing ensures that sensitive data can be appropriately protected and accessible for collaboration, while proper data segregation ensures that information is segregated according to company, geographical, or jurisdictional requirements. OpenDSU provides a powerful conceptual approach through DSU's data sharing units, the BDNS, blockchain domain naming system, and the naming scheme for DSUs called KSIs, key self-sovereign identities. The second layer is data volumes. Built on the secure sharing and segregation of data, scalability is necessary for a platform to handle a high volume of transactions and interactions across multiple independent but interoperable ledgers. As it is impossible to build a single ledger that can scale with the number of transactions required by the whole industry, OpenDSU offers a scalable and interoperability solution with the DSU concept. The third layer of our model revolves around consensus and scalability. A well-chosen consensus mechanism is vital for scalability and flexibility, allowing for efficient management of complex business logic by favoring local or optimistic consensus over a global one. The concept of self-validating data, SVD, originating from the layer above, also offers a solid alternative approach for the consensus mechanism layer. This offers immense potential for scalability and computational integrity, transforming how we approach these key aspects of the platform. The fourth layer is the privacy and confidentiality layer. This layer employs encryption, data anonymization, decentralized identities, and decentralized access controls to safeguard trade secrets. It builds upon and encapsulates the collective benefits of all the preceding layers. Various approaches, like anchoring mechanisms from OpenDSU plus SVDs and IPFS, on-chain methods like ZKP, or even complex tweaking with enterprise databases and secrets management systems like in Hyperledger approach, can be utilized. The paramount objective is to safeguard data privacy and confidentiality without compromising the platform's comprehensive functionality. Various business and technical constraints will inevitably influence the choice of confidentiality mechanisms. The topmost layer in our model, the computational integrity layer, ensures the platform's computational accuracy. Through various mechanisms, this layer certifies the validity and correctness of operations carried out within the system. The key insight from PharmaLedger is the understanding that a one-size-fits-all approach can have significant drawbacks. It underscores the need for a nuanced and balanced approach to effectively maintaining the platform's integrity. Zero-knowledge proofs, ZKP, are a promising mechanism to enhance trust in a shared platform, but should not be seen as a cure-all. Throughout the PharmaLedger project, the self-validating data (SVD) concept ventured into pioneering territories as an alternative approach to this intricate problem. The main insight is that enterprise use cases and permissionless blockchain networks for payment-related use cases hold different risks regarding computational integrity. For enterprise use cases, a certain level of trust can be established through commercial contracts, code reviews, and offline integrity checks. The main insight we wish to convey is the absence of a universal and solution for all problems. OpenDSU offers complex solutions beyond basic on-chain approaches, addressing a range of emerging issues. We encourage those interested to explore the OpenDSU YouTube channel and visit OpenDSU.com. OpenDSU introduces a variety of concepts such as DSUs, enclaves, HSMs, the use of zero-knowledge proofs, ZKP, and the notion of microledgers with self-validating data, SVD, each having its unique strengths and applications. A secondary insight addresses limitations in Hyperledger fabric channels, private data collections, and DIDs with ZKP. For a detailed discussion, feel free to reach out to us. Notably, DIDs implemented using BDNS emerged from our collaboration with the W3C DID community, which has struggled to promote its standards. We advocate for the development of practical, impactful applications as the best way to establish effective standards. Our third insight focuses on the need for evolved thinking in wallet and key management. Misunderstandings and resistance to change are common in this area. OpenDSU's approach to portable wallets, offering digital sovereignty to users, challenges traditional practices. Further discussions on key management practices will be available on our YouTube channel. The fourth key insight revolves around data sharing and segregation. OpenDSU's DSUs, BDNS, and KeyEyes provide a unique and advanced approach, unmatched by current technologies. For those interested in architecture or research, Our fifth insight discusses the feasibility of using multiple ledgers in parallel and the innovative concepts of nanoledgers and microledgers in conjunction with self-validating data. Another non-technical insight concerns the impact of existing standardization efforts, which may hinder innovation. For instance, the PCIS standard by GS1 poses challenges due to potential conflicts with the decentralized security model and the EPCIS capture and query interface. A potential solution involves storing a digital twin in DSUs. However, aligning this with the EPCIS standard and integrating appropriate cryptography is complex. Initially, creating a web interface fully compatible with EPCIS might be impractical. Instead, we will develop an interface tailored to the new system's needs and limitations, with plans to enhance compatibility and interoperability in collaboration with GS1. In our continued discussion on computational integrity and privacy confidentiality, we will explain how diverse technologies like DSUs, OpenDSU enclaves, and others suit different use cases, underscoring our belief that specific technologies are needed for each use case category. The complexity of these topics precludes detailed exploration in this presentation. Our goal is to inform architects and business stakeholders about the subtleties of blockchain enterprise solutions. A thorough review of each topic would require extensive time. We reiterate, our research clearly demonstrates the necessity for enterprise blockchain applications to evolve beyond purely on-chain methods, such as exclusive reliance on smart contracts, with or without zero-knowledge proofs, ZKP, for computational integrity. We have shown the effectiveness of microledgers and nanoledgers, the latter based on a simple DSU approach, in ensuring integrity and traceability without sacrificing scalability, performance, or confidentiality. The diagram presents tailored solutions for 4 identified use case categories, transcending specific business needs. These include data anchoring or NFT-like models, decentralized business process modeling, decentralized choreographies, network-wide governance systems, trustless choreographies, and standard applications like cryptocurrencies or DeFi protocols. For data anchoring, nanoledgers, as in DSU anchoring, are suitable. Decentralized modeling benefits from combining microledgers with DSUs. Conventional applications align well with traditional smart contracts, whereas network-wide governance systems are best served by integrating micro or nanoledgers with ZKP-backed smart contracts. This indicates a need for diverse blockchain technologies based on specific use case requirements. To support these recommendations, we identified 3 key characteristics or risks. 1. The number of stakeholders, considering participant count and data ownership. 2. Privacy measures, including requirements for encrypted peer-to-peer communication. 3. Methods to prevent undesirable behaviors like spam attacks. These aspects vary in applicability depending on the use case, as formal agreements between participants are crucial for clear enterprise system interactions. We hope this clarifies how non-functional requirements and risk mitigation for the top 4 solutions are influenced by these characteristics. The presentation aims to highlight the intricacies of blockchain enterprise architecture and position OpenDSU as a viable, nuanced solution. OpenDSU standardizes reusable concepts and components, easing the implementation of decentralization, APIs for blockchain-anchored data, creation of digital twins, and tokenization. Nanoledgers and microledgers are essentially equivalent to tokens as understood by the Ethereum community. We acknowledge the complexity businesses face, noting that overlooking security by design and confidentiality can lead to significant impacts, affecting adoption and the long-term effects of digitization on society. Therefore, discussing decentralization is essential in an era increasingly dependent on digital solutions. As we come to the end of our presentation, I'd like to extend a heartfelt thank you for your attention and engagement. If you found this discussion intriguing, we encourage you to explore further or contact us for an online meeting. If this is your first encounter with DSUs, I encourage you to explore other presentations on the OpenDSU YouTube channel or visit the OpenDSU.com website. In various presentations, we explain in detail the benefits of the DSU concept in the context of the insights we have acquired from implementing enterprise blockchain at the research or production level. Currently, most blockchain solutions are centered around APIs that presuppose the existence of databases, leading to blockchain usage that often seems like an afterthought, offering minimal benefits and straying from the principle of decentralization, which is founded on digital sovereignty and efficient data segregation. One key insight we want to share is that the concept of the data sharing unit, DSU, is as fundamental as well-known notions like files, zip archives, or remote procedure calls, RPC. Proper decentralization requires this concept to be imagined. However, the adoption of new ideas, especially those emerging from academic research rather than major corporations, can be a gradual process. The DSU approach differs by not relying on complex cryptography like zero-knowledge proofs, ZKP. Instead, it embodies the principle and benefits of ZKP, but allows for an interactive approach for data sharing and traditional cryptographic methods. Traditional ZKP methods are non-interactive cryptographic protocols that, while valuable in certain contexts, are less flexible and safe than OpenDSU mechanisms. The DSU concept, with its granular access control, proves to be more adaptable and effective for enterprise blockchain applications. While ZKP is proficient in validating public business logic, the critical challenge in enterprise scenarios often revolves around data sharing. We are optimistic about the potential of these advancements to make the world a better place under the concept of digital sovereignty. Particularly in countries where the supply chain is not yet regulated by the state, or in use cases where adoption is blocked by centralization, OpenDSU's way of thinking offers a more comfortable and business-friendly alternative. We are excited about the benefits of decentralization, cryptography, and digitization, and are committed to realizing these in a way that is harmonious and positive for everyone involved. Thank you once again, and we look forward to continuing this journey towards innovation and improvement together.